Hello, I'm Vanessa, and I'll be presenting a paper I co-authored with Anne Cameron titled EXPLORA, a teacher-apprentice methodology for eliciting natural child-computer interactions. EXPLORA is a methodology based on exploration through teaching and apprenticeship, aimed at online studies. Through EXPLORA, children and caregivers teach us, researchers, their ways of using devices and apps. The ways of using devices and apps cover interactions, problem-solving, and decision-making strategies involved when they interact with devices and apps. As children teach their ways into interacting with devices and apps, they provide context-enriched interactions. Through EXPLORA, we analyze these context-enriched interactions to provide practical design recommendations that support children's interactions, problem-solving, and decision-making strategies. What motivated the development of EXPLORA? EXPLORA is a context-enriched methodology. Context-enriched methodology focuses on understanding how users interact with devices and applications in contexts. Context-enriched methodologies can capture behavioral, attitudinal, and a combination of behavior and attitudinal data. And here are a few examples of methodologies for each of these categories. Besides the challenges involved in gaining access to a natural study setting, context-enriched methodologies have other challenges, such as defining or limiting what context factors have a greater impact on interactions, and enlisting frequent real-life interactions, as these are not always reported or observed due to the limited time frame we spend in the study setting and with participants. Since design recommendations are mostly based on what is reported or observed when it comes to context-enriched studies, these recommendations may not align with what children need in order to support their interactions with devices and apps in real-life contexts. Now, let's dive into the EXPLORA's conceptual framework. EXPLORA's foundations relies on the interplay between context, agents, and interactions. We consider context as an interconnected system involving settings, situations, and constraints. Settings are the space, situations are the events and activities, and constraints are the opportunities and limitations presented to the child at the time they are interacting with devices and applications. Agency is the capacity of a child to exercise and manifest their actions based on internal and external conditions, and interactions encompass actions, inputs, and outputs involved in children's engagement with devices and apps. Building on this foundation, we designed EXPLORA to be a multimodal methodology where we start collecting attitudinal data that will inform us in the subsequent stages of data collection. For the attitudinal stage, we utilize interviews, and our goal is to understand child's terminologies, what kinds of devices and apps they use and would like to use, and why, child's perspective on their frequent interactions and constraints. This preliminary understanding will prepare us for the subsequent stages of EXPLORA. For the behavioral stage, we facilitate observations to capture frequent interactions, constraints, and problem-solving decision-making strategies as the child perform a natural task. For the behavior and attitudinal stage, we use two approaches: events-based sessions and a reflexive interview. In the events-based sessions, children are encouraged to discuss and reenact recent experiences. The goal here is to obtain more contextual data based on the child's perspective, the ideal and not so ideal situations, constraints, and problem-solving decision-making strategies. In the reflective interview, we bring our preliminary assumptions and seek participant validation. Children are our teachers, so we ask them to grade us. Speaking of children being our teachers, we include the prompt, "Can you teach me?" in the data collection protocols. Our goal is to provide a minimum guidance to children and help them feel comfortable in sharing their experiences and being the expert by assuming the role of the research teacher. For example, during an events-based session, while the child is talking about their experiences with YouTube, we can ask them, "Can you teach me how you use YouTube to find what you need to complete your homework?" And the child's response will be demonstrating their interactions, constraints, problem-solving, and decision-making process to complete their homework. This example will be more detailed in the coming slides. Besides the multimodal approach based on the interplay between context, agents, and interactions, we also include a framework to organize and inform data analysis. We employ the cognitive work analysis means-ends analysis framework. The CWA means-ends analysis involves decomposing complex tasks or activities into distinct steps, the means required to achieve specific goals, the ends. As you can see in the figure, the means-ends analysis has 5 different levels: goals and constraints, priorities, activities, processes, and resources. We employ the means and analysis to identify and understand frequent situations, constraints, problem-solving, decision-making strategies, which in turn help us identify what design recommendations should be prioritized. Case studies. We applied EXPLORA in 9 single case studies with Brazilian child-caregiver pairs. It was a 7-week online study we conducted over Zoom, Skype, and Google Meet. We asked each child-caregiver pair to choose the platform that they felt most comfortable working with. These case studies aimed to understand how Brazilian children use devices such as laptops, tablets, and phones, and apps to complete homework tasks. In the next slides, I will present some quotes to illustrate what EXPLORA helps elicit during these case studies. During the interview, Mary was talking about how she usually searched for homework information. And she said, I use my phone and my mom's laptop at the same time. This was a great opportunity to follow up with our prompt. Can you teach me how you use your phone and your mom's laptop at the same time to complete a homework? Mary described the steps she took to search for homework information. I get the video from TikTok and go to the laptop. I type the title on Google and check the links. Now in the observations, Philip assumed his role as our teacher and wanted to give us a glimpse into what he normally did. Mom, you're not teaching R correctly. I don't use the tablet all the time because it's slow. However, his mother, Brenda, replied, but you're using it now. So we need to teach R. What are you doing? We can explain that to R when you finish your homework. Philip's mother also wanted to show us that Philip needed to learn how to use the computer, as she thought it was the best for him. In the events-based sessions, the children spontaneously kept journal of what they did in the week prior of our study session. These journals were their lesson plans, as evidenced in the code by Aries. I have a list with all the things I did last week. I can choose something from the list to teach you. As you can see in the researcher's code, we encourage Iris to choose what she thought it was most interesting to teach us. And Iris picked one topic in her list to teach us. I want to teach you how I searched for the answer to my cardinal directions homework. Finally, in the reflective interview, we concluded by asking children to grade our preliminary assumptions. We started the session listing all the things we had learned. In this example, we wanted to confirm with Russell about his preference for searching videos on YouTube. And then we said, I learned that Russell likes checking if other children's projects work before trying it. Is that correct? But children are used to correcting adults, as evidenced in the quote by Russell. But his mother intervened by asking, are you sure? And Russell felt more comfortable with correcting our preliminary assumptions. No, my mom asks me to check if my idea is going to work before we spend any money. I'll present a overview of the means and analysis and the resulting design recommendations. Here's the complete means and analysis resulting from the case studies. The focus here is just to illustrate the application of the means and analysis rather than discussing the findings for the case studies. Here I am highlighting the processes because they are the result from the constraints of each level in the means and analysis. Now that we understand what, how, and why contextual factors, in other words, the levels in the means and analysis affect children's interactions, how do we translate the means and analysis into design recommendations? We use a framework where we map frequent scenarios children encounter and propose functions based on children's problem-solving and decision-making processes, as well as their cognitive abilities and constraints in their contexts. Here's an overview of a homework tutor that came up based on our means and analysis. We found 3 frequent scenarios and proposed 9 functions. This design recommendation framework helps us link the functions and actions not only to the processes, but also to contextual factors and children's agency. In other words, problem-solving and decision-making strategies. Discussion. In what ways was EXPLORA helpful? We found 4 categories that suggest that EXPLORA may be helpful in enlisting rich contextual data from natural child-computer interactions. Method sequence. We suggest that to design a study to capture natural interactions, researchers should consider starting with attitudinal methods and follow with behavior methods that help us gain a better understanding of children's terminologies, context, agents, and interactions before going to the field. Child caregivers as teachers. Introducing guidance in natural studies has been a long-standing challenge because guidance can interfere with how participants perform during natural observations. However, we found out that the prompt, "Can you teach me?" helped us elicit reports and demonstrations that happen frequently and especially encourage children to feel comfortable with their ways of interacting with technology. Contextual relationships. We developed a methodology that helps researchers identify what contextual aspects might might have a great impact. In the group of children being studied, addressing long-standing challenge in context-enriched methodology, which is understanding what contextual factors can be left out of the analysis and don't impact design recommendations. Design recommendations. EXPLORA methodology provides a framework for deciding what design recommendations to prioritize. This addresses a key concern in the HCI regarding how field studies can establish a connection with interaction design. Conclusion. Today we introduce EXPLORA, an exploration through teaching and apprenticeship methodology. EXPLORA translates context-enriched child-computer interaction into practical design recommendations by considering the interplay between context, agents, and interactions. Thank you for watching our presentation. Feel free to reach out to us if you want to know more about our research or access our full paper by scanning this QR code. Thank you.